Ya Allah Allah.
Of the consortium project Find Force, enhancing higher education capacity for sustainable data-driven food system in Indonesia. I am delighted to welcome all of you to today's guest lecture. My name is Francis Amati, and I'm honored to serve you as your host for this special session. Before we begin, I would like to kindly remind everyone to please keep your microphones mute during the presentation to ensure a smooth session. You are also welcome to use the chat box for greetings or later during the Q&A session. Tidar is part of Forest Initiative, a project that aims to enhance the capacity of Indonesian universities in teaching sustainable food systems. This project is built through strong collaboration between several European and Indonesian universities, aiming to strengthen education, research, and innovation of in food system sustainability. It's our great privilege today to welcome our distinguished guest speaker, Dr. Rajat. Dr. Rajat is an assistant professor of biological engineering at University College Dublin and a chartered engineer with Engineers Ireland. His work primarily focused on sustainability, life cycle assessment, and the health impact of climate change. Additionally, Dr. actively leads international collaborations and serves on the editorial board of Science of the Total Environment. Today, he will be delivering a lecture titled Advancing Food Safety, Predictive Modeling and Quantitative Risk Assessment approach developed at UCDSPFE University College Dublin. Without further delay, please join me in warmly welcoming Dr. Rajat. Dr. Na, the time is yours. Very much for the kind introduction. I appreciate that. And it's kind of some ground rules. So I think total duration of this tutorial will be 90 minutes, right? So I try to finish my lectures by 1 hour 15 minutes. So I'll set the timer for 50 minutes first, and there will be a break. And then after like 5 minute break, during the break actually you can watch a YouTube video. I have the link here. And then like second part will be covered after that. And then if you have any questions, feel free to ask. I have entire kind of duration of time for discuss, but like it's up to you
how long you want to continue the discussion. So, okay, thank you very much again. Uh, for the students, I would like to request the students if you can keep pen and paper handy, but it will not be long. So at some point in time in my presentation, I request you to take some small notes for some future slides. And yeah, so I also encourage one-to-one kind of interaction, or if you have any doubt at any point, feel free to stop me and ask me, and if I go too fast. Uh, it was a pleasure to be among you for the first time in Indonesia. So the amount of love we received from all of you is it will be a kind of lifelong asset for me. And yeah, and see the gender ratio here. So I was very much overwhelmed with the women empowerment, which I evidence in terms of the participation. So this is something got in mind, and the conference also going very well. And before I start my presentation, I would like to give you some idea about the president vision. Most of you know already. But when I was doing some research on this country, the vision regarding the food and business and all, so I think the president's vision is very much clear, which aims for food sovereignty and self-sufficiency as the basis of national independence. It promotes technology-driven large-scale agriculture to boost productivity and efficiency, encourages collaboration among government, military, academia, and private sectors. The last point is very important. Seeks to make Indonesia a global food state, supporting other nations. So that's kind of a vision of the good person in terms of helping others through sustainable production. Sustainability also very important nowadays to meet all these 17 sustainable goals across the globe. That's the priority to save our planet. So based on that, I was also trying to search what are the challenges, because sustainability comes with some effort. For a metaphor, the thing which doesn't require any care and all is kind of the chaos. Like I get naturally dandruff on my hair, right? So to make it sustainable, I need to take care. I need to wash my hair with shampoos and all, right? Anti-dandruff shampoo. So this is kind of we need to put some effort to meet these sustainable development goals. So I actually searched the problems for Indonesia in terms of the food, environment, and human health and pollution, because that's my also focus area. And yesterday I found there are like 22 papers in this field. So link is there. So I'll send you a copy of a PDF copy of this presentation after my talk. Feel free to explore those links to see the traceability of the data. And so I downloaded all these 22 papers. I made a word cloud, and I actually like the national bird of Indonesia. So I thought, why not to make the word cloud in that form? So you can see here the most appearing words are microplastics, heavy metals, lead pollution, arsenic, then mercury, food safety, and fortunately or unfortunately, these are all my focus area. So I perform risk assessment as applied to microbial and chemical risk. And in the past or currently, I'm actually doing my research in those areas. So I've been delighted to share my findings, and also most importantly, the methodological development in risk assessment. So now you can take few notes as I mentioned. So any risk assessment can be classified into three categories. Very simplistic one is the qualitative model. The next one is called the semi-quantitative model. And the third one is the sophisticated one, which is called a full quantitative model. So in qualitative model, there's a simplistic one, we assess everything in terms of probability and impact matrix. Say for example, probability, what is probability? If I say, so this is just hypothetical to make you understand. I'm not saying these are the facts. Suppose you eat tofu, right? So sometimes out of 50, one tofu can be contaminated with bacteria, right? So what is the probability of this contamination? If anybody can volunteer, I said one tofu can be contaminated out of 50 samples. So what is the probability of getting bacteria in the full sample? Anybody? No. So I said 1 in 50. So what would be the number for 100? It's 2, right? Just multiplication. So there's a 2% chance. So there's a 2% probability that my food can be contaminated based on the food sample, or the food sampling and the testing. But now the second concept called the impact. So impact is, so it can be contaminated with many kinds of bacteria or so it can be salmonella, it can be Pitosporium, it can be Giardia, so on. Okay. So if you are exposed to 10 numbers of bacteria, 10 numbers of viruses, so the impact will not be the same, right? Because you need as minimum as 5 to 10 numbers of norovirus to get ill. Okay? But you need 10 to the power 8 number of, say, or 10 to the power 11 number of listeria to have the same sickness. Are you getting my point? So the probability is something, the occurrence or the likelihood, and the severity or the impact of that hazard, that is captured in impact score. So when you multiply the probability multiplied by the impact, that's your final score for the qualitative model. Suppose you want to score them from 1 to 5. So for probability, you have a score from 1 to 5. For impact also, you have a score from 1 to 5, right? So the maximum, what would be the maximum risk score? 5 multiplied by 5, 25. And see, if you can see on my slide, I have 3 colors, green, yellow, and red. So this is called 3 classification system, like low, medium, and high. You can also actually classify that into 5 category system, say very low, low, moderate, high, and very high. So based on the number of classification, you just divide the maximum number by 3. So we are using 3 classification system, right? So we divide 25 by 3. So roughly it is 8 something. So we need to set that interval in terms of 1 to 8, 8 to 16, 16 to 25, something like that. So if you can see the classification system here, so 1 to 7, I suppose, is considered as low. 8 to I think it's 8 to 1 to 6 considered as low. So why this 7 is coming? Okay, 7 is not there actually. Okay. So 1 to 6 as low, 7 to 12 as medium, and 13 to 25 is high. The thing is, for the qualitative model, is depending on the assessor. So how I classify the system, somebody can also give score of 1 to 7 as low. But there is no like kind of hard and fast rule. But both of us should come with the same conclusion or similar conclusion. Say for example, your local county council is evaluating 2 different sites regarding the risk of flooding. For example, you in 10 years or some like 15 years, maybe you are going to buy some house. So how to assess where to buy the house in terms of the flooding? If Indonesia is prone to flooding, say for example. So these are the categories which can influence the flooding, such as rainfall. So rainfall is the cause. If there is no rainfall, there is no probability of flooding. The next is the closeness to main river. So if you are living away from a river, the chances of flooding is very low. Then the type of soil. So the clay contains a lot of water clay actually hold clay soil. But if you have a sandy soil, the water can, like the drainage system is very good. So water can infiltrate into the groundwater. So it is not a kind of a cause for flooding. So these are the parameters. Now you have selected two sites based on proximity to this institution, say. So you need to drive by, and you selected two sites for this house building. So one is located in an area subject to occasional rainfall. So this is parameter one, as determined by like meteorological data or like the climate authority data here. It is within 1 kilometer of a main river, the soil of heavy clay soil. There are very few impermeable surface on the sites. So impermeable means like if you build your entire city with concrete roads, will the runoff or will the rainfall penetrate into the soil? No, right? Because you covered all the soil, all the land with concrete, right? So water can only flow on top of the surface. So that also creates the flooding. See, for example, uh, based on the some knowledge, some background knowledge, so you need some background knowledge. So, for example, a civil engineer can assess that. So the probability of rainfall, say if I score it as 2, the closeness to main river, that is that firstly identified as the most vulnerable parameter. So if it gets a score of 4, the chances, then others can get a relative score. So the rainfall can be given a score of 2, the type of soil can be given a score of 3, amount of impermeable surface, that is also very important parameter for like urban population. So that can be also given a score of 4. The impact, however, for these two scenarios, site 1 and site 2, should be the same. The probability can be changed. So based on the relative impact, so the first parameter was given an impact score of 4, next 2, 3, and 5. So that is the same for site 1 and site 2. So the next one is the condition is site 2 located in an area subject to high rainfall. So that's why it is given a score of 4, probability score. It is 2 kilometers from a main river. So as compared to the first scenario, it gives a score of 2. Then the soil is lightly sandy loam. It's like it's not like clay. So if I give a score of for the probability for the clay as 3, it can be given a score of 2. So it's not that sandy, but in between sandy and clay. So the last thing is, I think, is the same score because it's the kind of the same value. So then you multiply 2 multiplied by 4 is 8. 4 multiplied by 2 is 8. Like the row wise, you multiply. And these are the risk score for individual parameter. And then when you add 8 plus 8 plus 9, so that is plus 20. So that is your 45 score for site 1. And you get 46 score for the site 2. Now, could you please tell me who is the winner? So where should you buy your house? Site 1 or site 2? Site 2? No. Site 1 is 45. Yeah, site 2 is 46. Yeah. So you should go for site 1. So that is the qualitative model. Okay? Understood? Next one. This is something more sophisticated as compared to the qualitative model. So we call it semi-quantitative model. So it is not the fully quantitative model. So it is the second chapter of my PhD. So I was trying to do the risk assessment of spreading organic fertilizer or anaerobic digestate on land. So let me introduce you first what is anaerobic digestion plant or the biogas plant. So anaerobic digestion plant is the biological process which can utilize farm manure and slurry along with the food waste to generate biogas. So it's a natural process. You can also use garden waste, grass to balance the carbon and nitrogen ratio, and some like substrate like bacteria from the previous batch, and we can like give kind of like detention time, say for example 7 days or maybe 2 days, or for big anaerobic digestion then we can give a retention time of say 2 to 4 months also. So basically it generates methane which can be used for heating buildings or generating electricity, and the digestate which remains after this treatment is kind of a sludge which can be applied to agricultural land because it's a nutrient rich organic material, and it acts as a soil conditioner to soil. So anaerobic digestion can inactivate a lot of pathogen. So what are the pathogens? So I did the literature review and found there are like 91 pathogens of concern which can be present in raw manure and soil. Okay. So this anaerobic digestion process can inactivate a lot of pathogen, but complete inactivation is very unlikely. So there is a chance that you will have some amount of bacteria after the process. Maybe you can inactivate 99%, which is kind of like too low, but like that 1% can grow over the time and cause problem in the future. So I wanted to scope them based on 3 parameters. One is the thermal inactivation score. If the bacteria or viruses can be inactivated fully, so like 99.999%, it gets a score of very low, say 0.1 or 1. And if it cannot be inactivated, so it survives all these digestion process, so or the pasteurization process, it gets a score of 1 because it cannot be inactivated. So highest score is 1, lowest score is 0. Okay, understood? First parameter. Second parameter was the transmission pathway. So once you apply this fertilizer on land, it can spread through air, water, and food, and also zoonotic route. Means like if you are petting a horse, petting a cow in the farm. So some pathogens can also transmit into your body. So out of these 4 pathways, I try to assign similar score for all. So the sum should be 1. So for each pathway, I gave a score of 0.25. So 4 pathways. So if one pathogen can transmit through 2 pathways, what would be the score? I said I assigned 0.25 for each pathway. If one pathogen can transmit only through air and water, these 2 pathways, what would be the score? Yeah, 0.5. Yeah, so if one pathogen, say for example, cryptosporidium, can spread through all these 4 pathways, so it gets a score of 1. The last one is for the impact. So first 2 is kind of a probability score. The last one is the impact score. Means like what is the probability of getting a death or the mortality if the patient is untreated, like they are not given any medicine, if they are not visiting the doctor. So based on that mortality score, 10% mortality say it gets a score of 0.1, 100% mortality gets a score of 1. Because in probability, 1 is the maximum score, like 100%. Probability cannot be 1.2. So you know now I multiplied all these 3 parameter, and in the right hand side you can see the bar chart. So that's the ranking of all these pathogen. Out of these 91 pathogen, I found Cryptosporidium, Streptococcus, Entamoeba, Salmonella, Ascaris, E. coli pathogenic. These are the most kind of concern for us. And like the list is very big, I cannot accommodate that. So, but the main point was that was the main reason of doing the ranking. If you do PhD in the future, you will see like God will give me the responsibility to solve all the problems, right? True, right? So I tried to narrow down my scope of research because within 3 years I was not able to conduct this assessment for 91 pathogen. So this is the chapter just after the literature review. And then I considered these top ranked pathogen for my next chapters. So how you can actually narrow down your scope of research is very important. So if you just say in my case, this is I looked at Cryptosporidium and Salmonella. But people will ask you, what is justification? Why not say Campylobacter? You do not have any answer. But in kind of research, you have justification for every single comma, full stop and all, right? So for the writing also, the rule of thumb is if I delete a sentence from your thesis, if your sentence makes the same sense, there is no importance of that sentence in your thesis. So ask yourself, how much should I write? If you can communicate your entire thesis within 40 pages, that is also fine. Okay? So I'm saying you should have justification for everything in research. So now come to the final thing, which is called the quantitative risk assessment framework. So this is the most sophisticated one. So risk analysis is a three-step process starting with risk analysis is a three-step process starting with risk assessment. If there is a risk, we need to communicate that among the stakeholders and minimize the risk. So that is called risk management. Within the risk assessment, we have 4 steps. It starts with the hazard identification. If there is no hazard, there is no need to conduct risk assessment. Next, we have 2 parallel steps. So there is no order of step 2 and 3. So in some paper, you can see hazard characterization is conducted first, and in some paper exposure assessment is conducted first. In hazard now, you should take some note on that. So these are the steps: hazard identification. Main purpose, identify the hazard characterization. We check how much or how many of this pollutant can cause harm to my body. Okay? How much or how many pollutant can cause harm to my body. And in exposure assessment, we calculate how much or how many of this pollutant we are exposed to on daily basis. Like how many numbers of bacteria can enter our body per day. So that is called exposure assessment. And in risk characterization, we integrate hazard characterization with exposure assessment. We evaluate the final daily probability of risk, and then we extrapolate that to annual probability of risk. For a probabilistic model, scenario analysis and severity analysis are performed at this step to identify what are the sensitive parameters of this model in terms of the uncertainty associated with the data. So, do you love boxing? Anybody? Nobody loves boxing? But do you know the moves of boxing, the names? Hook, uppercut, and jab. You know. So, for the literature review of this hazard characterization, I went through maybe more than 800 papers, and I found there are fundamentally 2 kinds of dose response model. So dose means the amount of bacteria, and response is what is the response. Response can be infection, illness, or death. So when I eat a contaminated food from the street, I'm not saying you should not eat street food. I love street food. But if I eat street food and the next day, if I get any problem, stomachache or something, so that is called illness. Okay? But if I have prolonged issue with that, like I'm suffering from the stage diarrhea and all for 7 days and all, so that is called infection. So there I need medicine, antibiotics, right? And the third is very simple. Third endpoint is death. Okay? So it starts with, so write it down, the steps: illness, infection, and death from the order. So that's the order of the response. So there are 2 fundamental models. One is called the exponential model. So this is equation 1, where probability of daily infection can be achieved through this equation, 1 minus the exponential of minus r multiplied by n. So that r is the statistical fitted parameter based on the experiments, and n is the number of bacteria you are exposed to on daily basis. Okay. So how this r is calculated? So, for example, from the animal study, based on mammals, we actually depend on mammal study, such as rats and all, mice. So we give the rat or mice the amount of bacteria through food. It's called gavage, forceful feeding, and see at which concentration of the bacteria they are developing symptoms like diarrhea, vomiting, and all. and then we extrapolate, or sometimes we just use based on the body weight. So what would be the number for like us, like for human? So we actually extrapolate them. So when fitting the data, when fitting a curve on the observed data, it is generally kind of an S-shaped curve. I'll show you that later. So that is the equation one, and the next model is called the beta Poisson model. So that is equation two, where the daily probability can be calculated based on 1 minus 1 plus n. So that is the number of bacteria we are exposed to on daily basis. And then we have 2 to the power 1 by alpha. So alpha is also a fitted parameter based on the data, minus 1 divided by n50. So n50 is the number of pathogen required to cause 50% illness in our body. Okay, so it can be 10 to the power 4, it can be 4, it can be 3. For some deadly viruses, it can be 10 to the power 15. And then we also have to the power of third bracket like minus alpha. But equation 3 and 4 are the same form of equation 2. So you can find these three forms in papers. So once this P daily is calculated, we calculate the P annual. So what's the annual probability of risk? So that is based on the following equation: 1 minus in bracket 1 minus P daily bracket close to the power of number of days consumption. So I'm coming back to the street food, say contaminated food. So that power number of days should be the number of days I eat street food in a year. Got my point? So if I eat 7 days in a year, so that after the bracket, the to the power number should be 7. Okay, all good? Nice. So there are some challenges always because the studies are not uniform. Because you can conduct one study in like Indonesia, I can conduct a study in India, somebody can conduct a study in Ireland, and also the humans and the animals are not the same. So this is something you need to do kind of a practice before you use any random dose response model. So make a table, name like studies 1, 2, 3, 4, 5, the number of studies you can get from the literature. If you do not want to do any lab test, then you can also gather the information from the literature. So the reference, original study, yes or no? No means they didn't conduct the animal study, but they referenced Golden et al. 2009. So that's the original study. So it is also important to trace back what is the original study of this animal model. And then listen carefully, this is very, very important. The sample or the host type. So this dose response model can differ if I apply this model to human, if I conduct the experiment on mice, if I conduct the experiment on rabbits and horses, and so on. So this is also important to write down on which kind of species the test was conducted. And then the best fit model. So it can be exponential. In some paper, you can identify this as a beta Poisson model. And then these are the equations. So from my previous slide, so equation number 1, 2, and 3 or 4. And then these are the optimized parameters. So R for the exponential one, for beta Poisson model, it can be alpha and n50. And the root is also important because for the same pathogen, sometimes it can contaminate our eyes and the stomach at the same time. So so for example, one pathogen, if it is traveled through air, so from the general information, just tell me one thing. If I inhaling that pathogen in the air, so what should be the endpoint? Like the lungs or the stomach? No, stomach is like when I'm eating, but when I'm inhaling, it goes to the lungs. But there is a twist. So here in the trachea, we have two parts, right?
Yeah.
So one goes to the lungs, one goes to the stomach. Sometimes the pathogen can also attach to the mucus and it can slip into the stomach. So for the same exposure, you have multiple response. Like it can affect stomach and your lungs at the same time. Are you getting the thing? So these are the in-depth kind of thing you need to go through when you conduct research. So, for example, I have the number 8 or like 5 number of studies. Now I need to compare the curves. So based on the curve, if you draw the so based on these parameters, the equation 1, 2, 3, and 4, and the statistical feature parameters, if I draw this equation, it look like this. And then if you see the left side orange color, so that is kind of a conservative side. So if I add 95th percentile, or what is the kind of possible response to a same dose, and then I can use a cumulative distribution to capture all these variability. What I mean is, for example, for daily probability of 0.5, tell me which color is the most problematic one. So the x-axis your daily dose and y-axis your daily probability. For 50% probability of illness or infection, which curve is more problematic to identify the x-axis? So in the x-axis, value less means what? Problematic or non-problematic? So in the x-axis, if I have the value, small value, means the pathogen can cause problem at very small number, right? If I go towards the right hand side in the x-axis, so we have the higher dose. So for a same probability of 0.5, if I have higher dose of these pathogens, it is not so problematic, right? So tell me, the ash color or the orange color, which one is more problematic profile for the dose response model? Orange one, right? So if I highlight, if I use the highlighter or the laser pointer, this one, right? Laser. So for example, 0.5 for 50% probability, you need less amount of pathogen to cause problem. And for the ash color, it is here, like these value. So this value for the ash color curve is always higher than this value. So you got the point? So being in the safer side, now so this orange color captures all the possible kind of response in a conservative way. So if I use the orange color now, then I can ensure the safety. So this is a little bit complex, I know, but I wanted to give you the explanation of how you can combine multiple studies and take kind of overall summary for your research. So that's the end of chemical risk. Microbial risk. Now I'll go to the chemical risk. So this is very, very important. See here, similarly, this is the dose and this is the response. Okay. So here, this is called the state of the health. And this is the physiological response. So at this point, just check there is a black shaded area, and also you have black shaded area towards the end. For those black area, the zone is called the death of the zone of death. Why? I'll give you some example. For example, for our blood, what is the main ingredient to form blood? Element.
Iron.
Perfect. So which means this is the dose. So if I do not have iron, I'll die. Correct? So that's the area. And then this is called the deficiency syndrome. So most of the girls, due to the menstruation cycle, we have the problem of the lack of iron in their body. And during the pregnancy also, the pregnant mom given the iron tablets. Why? Because there is a deficiency. So in order to overcome that deficiency syndrome, supplements are needed. Are you getting the point? So this is called the deficiency syndrome zone. Then this is called the state of health. So that's the most preferable or expected outcome. This is called the low or mild health effect. Means like excess of iron can also be harmful. Okay, so this is called the low effect, and this is called the toxic effect from here to here. So this is very toxic. So you will develop some syndrome for having some element in higher quality. I'm saying element, it can be polluted also. For pollutant, maybe you don't have the beneficial kind of dose, you have the toxic dose. And towards the end, if I like start eating iron instead of like tofu and rice, then there will be problem, right? Because iron will not allow other elements to be absorbed in my body. So you die. So this understanding of curve for the chemical dose response model is very, very important. And then if I make a plot like dose and response like this way, this is the dose and this is the response, like the similar previous one, 0 to 100%. So it follows the exponential and the beta Gaussian model as I mentioned. So it is also kind of an S-shaped curve. Now take some point, the term NOAEL. It is called no observed adverse effect level. Okay, means this is the level up to which you do not develop any response. So you are giving a mice a pollutant substance, very little dose. Okay, you start not to give the mice any pollutant, and you are increasing the dose day by day. So the dose corresponding to this NOAEL, like no observed adverse effect. So that is called the NOAEL. So that is the amount of dose you require to have no response from that animal. Then there is something called LOEL. LOEL is where the curve changes its slope. Okay, so this is the zone where you will see the mice is not moving fast or it is not having proper food. Okay, so this is called lowest observed adverse effect level. Got my point? And then the phase called the exponential growth, and then it reaches the flat line. So what does it signify? The flat line here.
Yeah.
Perfect. So means like 100% response. So state. So in chemical risk assessment for any substance, we have three thresholds. One is called the non-toxic or beneficial dose. So you'll be surprised to see. So I didn't make this graphics. It's from the Talks tutor. So alcohol, carbon monoxide like cigarettes and all. I'm not saying these are all beneficial because the dose corresponding to the non-toxic or beneficial dose. Beneficial, so this is something non-toxic should be mentioned for alcohol and cigarettes and all. Beneficial dose, we refer that to medicine. Okay, so do not mix with this thing. Don't tell like Dr. Nag told us alcohol and cigarettes are beneficial for health. Okay, so this is or non-toxic or beneficial dose. Then we have the toxic dose, means like if you're eating more sleeping pill will help you to fall asleep, right? If you're eating more and more, there can be your body can be toxic. The next one is the lethal dose, so you die. So you see the dose is increasing. Okay, from left to right. So what is toxicology? The study of adverse effect of chemical, physical, or biological agents on living organisms and the ecosystem, including the prevention and improvement of such adverse effects. Any question? Please.
Rajat, I'm just wondering, what it means about the non-observed efforts? Is it
Because-
effect?
Yeah, no difference whether you give the pollutant or the medicine to the mice or not.
So it's not benefit and not negative, right?
Yeah, so you cannot observe it. So you have in the study, you have the control group and the test group. So in control group, you do not give anything to that mice other than the food. In the test group, you mix the chemical substance with different dose with the food and feed the mouse. And for certain concentration up to certain level, you will not see any difference between this control group and test group. So that's the dose called Noel.
And how about the rules observed?
Lowest observed means like the control group mice, it is running or it's excited about the food, and the test group is like sitting calm in one place. Or it's not dying, it is not developing any disease, so there is no like loose motion or fever to the mice. But there is no mood of going for a football match. There is no mood of going to the class in human, not the mice. Yeah, so that's the difference, like from Noel and Noel. Thank you very much for the question. Okay. Okay, these are the factors which influence the toxicity, such as form and innate chemical activity, dosage, especially dose time, relationship, the exposure route, species, life stages such as infant, young adult, or elderly population, gender, male or female, ability to be absorbed. Sometimes you feel like in a class, you have a friend, you eat the same, but one is healthy, one is tiny, right? So this is because of the metabolism and how they can absorb the nutrients. Okay. Then we have the metabolism distribution within the body. So if the toxic substance is accumulating to one part, the response will be different. And if the toxic substance is mixed with all the parts of your body, the response can be different. Okay. Then excretion rate, health of the individual, including organ functions and pregnancy. So if you have underlying illness, then the response can be different. Nutritional status. So if you are malnutrition, the effect can be dangerous to you. And if you're healthy, if you have no deficiency of any elements, essential elements needed to grow cells, then the response can be different in your body. Then presence of other chemical, because some chemicals may not cause problem individually, but when they are accompanied by other chemicals, they start causing problem. So interesting stuff. Then circadian rhythms means like the time of the day the drug is administered. So when you go to a doctor, sometimes the doctor says like antibiotics, okay, you can take it in empty stomach or after the meal, right? But there are some medicine you can only have after the meal or before the meal. You know that, right? And there's a fixed timing. Like in the morning, you should take this medicine. My dad is a heart patient, so he takes certain medicine in empty stomach in the morning. It cannot be in the afternoon. Okay? So the time is also very important. Now we have some different kinds of toxicity, such as cardiovascular toxicity, we have dermal toxicity. So these are self-explanatory. I don't need to explain. Cardio means like heart, dermal means like skin. Then we have the genotoxicity. So that is transferred over like DNA alteration from one generation to another generation. Then eye toxicity, like nanoplastics or microplastics. So there are like 3 generations of study of mice, which I went through and found like toxic symptoms are observed in 3rd generation. Means like that is also scary. I know it is recorded over YouTube, but I don't have any hesitation to say 3rd generation toxicity means like our children and then their children may have some problem from these nanoplastics, but it will be too late, right? Because already their DNA can be altered or they can develop some problem. So means like we should be very concerned about our pollutant. It may not cause problem to us, but for our next generation can be the sufferer. Are you getting my point? Then there can be reproductory toxicity, there can be respiratory toxicity, there can be neurotoxicity, nephrotoxicity like kidney, immunotoxicity, and hepatotoxicity. So hepatotoxicity means like in the liver, with say for example mycotoxins, if you heard of aflatoxin, so it can cause liver cancer. So toxicity can be categorized into acute, subchronic, and chronic. Acute means immediately. Subchronic means like it takes several weeks or months, and chronic means like it can take years. So you have gone through the COVID, right? We all survived COVID-19. So we all had some medicine or some injections, right? So tell me now, was there any chronic toxicity tests on those medicines or injections? Injections only, right? We were given. Yes or no? How come yes? Because it was immediately given to people. Because you didn't wait for 2 years. Because otherwise, like half of the world would be dead. But it was not proven because for chronic toxicity, you can do the acute toxicity in on daily basis or maybe subchronic toxicity on weekly or 2 weekly basis. But you cannot do the chronic toxicity test within a month or two. Are you getting my point? Ask me question if you have. So you should observe the mice or the rat or maybe the volunteer human for 2 years or 3 years if they develop some problem with the medicine. But due to the urgency, the urgent nature of the situation, sometimes without chronic toxicity test, we need to give the medicine to people based on the situation. I hope COVID-19 or similar kind of disease will not happen in the future, but this is how we develop our medicine. Okay? Yes, please. It can be 5 years also. So depending on the outcome and the observation. Any drug we use, say paracetamol, say take any name, aspirin, aspirin, any drug should go through this kind of long-term test. Everything. I'm telling you, any substance which is treated as beneficial substance or medicine goes through this process. Okay? Then we have the carcinogenicity, means like it leads to cancer, developmental toxicity from mom to their babies, and then genetic toxicity, as I mentioned, alteration of DNA and like chromosome aberrations and polyploidy. So for the same substance, say for example ethanol, if you compare the acute and chronic toxicity, the endpoint can be different. This is also interesting. So for the acute toxicity, substance ethanol causes problem to a central nervous system, but for the chronic toxicity test, like effect, it actually causes damage to a liver. Okay, so this is very important to evaluate whether we are doing the short-term test or long-term test. Okay, so this is the sequence. Any kind of toxicity test starts with in silico modeling, means like computer simulation, to like my semi-quantitative model to reduce the volume of the work, and then we do in vitro test. In vitro test means like test tube testing, and then in vivo test means like animal testing. Okay, or the live cell. So it starts with in silico computer simulation, in vitro test tube analysis, and in vivo like live experiment. So for any in vivo experiment, it starts with the cytotoxicity test. Then if it passes that, then we do test on Daphnia, like the waterfly, and then when it passes that test, then we conduct that thing on smaller fish like zebrafish, zebra. Do you know how much DNA we share with zebra? 70%, something like this. I like that fish because it shares 70% DNA with me. Yeah. Yeah, small fish with that,
Yeah.
zebra kind of stripe. Yeah. So then we conduct test on higher order fish, and then we conduct test on mammals like rats, mice, and all, because we are also mammal. So then we also do the test on dogs and sometimes I think rabbit plus dog, and then lastly human. So if everything is non-toxic, and then we start doing the testing on human. Okay? Yeah,
ARFA.
I'm not getting it. Explain that.
So why is it?
Daphnia.
Yeah, sorry.
Oh, Daphnia. Daphnia is a water fly, which is an indicator species for ecotoxicity. To evaluate the ecotoxicity of any substance which is ecotoxic or not, we need to conduct test on Daphnia. So it's an ISO standard. So it's a water fly. So first it's called the immobility test or the mortality test. So we have 5 jars of fish tank. We use fixed number of water, and we use 5 number of daphnia in each, and then we increase the concentration of our chemical into all these things and see uh, at which concentration they stop swimming. So that is called the daphnia immobility test. And then for some concentration, they will die. So that's the lethal dose. So we have the from the immobility test, we determine the EC50 value. So effective concentration 50%. So means like at the concentration can cause 50% immobility in daphne. Okay? Yes, please.
So the Yamila
I do not know the other species. Sorry.
uh,
It can be. So it can be the higher order. So what is that? A kind of a fish? Oh, yeah. I do not know, but it can be the same. So that is higher order than the daphnia. So you need to conduct test on daphnia first, and then you can conduct also that test.
so it's standard for the drug development.
Oh, okay. So then it goes to maybe the mammals, because
Department.
yeah, because like there is animal welfare. You just cannot randomly pick a mice or something. You need to minimize the number of animal killing through the test. So that's why we do start with the lower order, then go to higher order. And these are the steps like mobility, reproduction, and mortality. And then these are the ISO and the OECD standards. So OECD and the ISO, these are parallel. So some of the experiments you can see OECD standards are used. In some you can see the ISO standards are used. So we can extrapolate the daphnia magna and the fish toxicity test to calculate the lethal dose 50 also for animals and humans. So this is the way we conduct test. Now this is the most crucial slide for conducting the hazard calculation for chemicals. So please pay attention. So it is an old method called benchmark dose method, and then the new one is like health-based guideline value method. So how we do that? So we conduct experiment like dose and response. We determine from the S-shaped curve and the confidence interval the upper kind of boundary for the uncertainty test, and we determine the Noel and Noel value. So once we know the Noel or Noel value, we need to calculate the RFT or the reference dose. We need to divide that Noel or Noel by multiple uncertainty factor, or UF1, UF2, and so on. So basically, 4 types of uncertainty can happen. One is the human variability. So I may respond differently as compared to you for substance. So that's called the human variability. Next is the animal study. So between animal study, there can be variability. Then less than chronic exposure. So, and animal study, I need to also explain things like It is not conducted on me. It is conducted on animal. So there is an uncertainty. Less than chronic exposure. So as I mentioned with the example of COVID-19 vaccine, so if you cannot do the test for 2 years, we cannot, so there is an uncertainty. So if you just rely on the test conducted on monthly basis or like 2 monthly or 6 month study, so that is not a chronic test. So that can be subchronic. So if you are relying on subchronic data, then there can be an uncertainty factor. Finally, Lowell instead of Noel. So if you cannot determine Noel value, Lowell can be used, and in that case, another uncertainty factor can be used. So 4 uncertainty factor, each can be valued as 10. So what is the total uncertainty factor? 10 to the power 4. 4 uncertainty factor, 1 values in 10. So it's like 10 multiplied by 10 multiplied by 10 multiplied by 10. So 10 is equal to 4. Remember that. So once this RFT is known, reference dose, then we use this thing, this RFT here in this equation to calculate the hazard quotient. Hazard quotient is nothing but daily intake of food multiplied by concentration of any chemical substance in the food divided by the reference dose and the body weight. Understood? So if the hazard quotient value is more than 1, we have problem. If it is less than 1, then the chemical is safe. Okay? Next, there are some problems because for some substances, they are very toxic from very beginning. So we cannot actually determine the knowing value. So for example, so just write down these two lines. If your substance is genotoxic and carcinogenic, the margin of exposure is 10 to the power 4 or higher. Okay? And if the substance is not carcinogenic or non-genotoxic, then your margin of exposure can be 100. Why 10 to the power 4? Because that's the multiplication of all those 4 uncertainty factors in my previous slide. Okay? So EFSA from 2023 adopted this new method called margin of exposure. So this is the development. So this is the dose and this is the response. This is the S-shaped curve. These values are the mean values. This is the upper confidence interval and this is the lower one. And when we join these mean values, and then we need to determine how much kind of factor of safety we want to have. So this is called the benchmark response or BMR, this point. And sometimes we call 5%, sometimes we also take 10% of that. So we increase that benchmark response by 5%. And then this straight line crosses this dotted line, upper confidence interval line of all these points. And then we get the corresponding X value. So this is called benchmark dose lower boundary. And then when this line touches this dotted line, the lower confidence interval, and the corresponding X value is called the benchmark dose upper boundary. Any question in terms of the understanding? So this is how we call this benchmark dose level range. So once this is known, then for margin of exposure for the genotoxic and carcinogenic, we use this margin of exposure equals to BMDL. So this is BMDL. This value we take here divided by the estimated exposure dose. Means like what is the daily dose we are exposed to. Then we calculate margin of exposure for non-carcinogenic and non-genotoxic substance. It's straightforward, Noel by the EDI. Because for non-genotoxic and non-carcinogenic, we can determine the Noel value. Okay? So these are the two fundamental different methods in terms of chemical risk assessment. Now this is for the self-read, and now this is a typical exposure assessment. Just go with the flow, just understand the story. So this was my students' PhD work. So we evaluated what is the risk assessment associated with treated wastewater for irrigation. So this is the irrigation water. Sometimes it can be from the wastewater treatment plant, the treated wastewater, because some part of the world water is not abundant. Okay, so we need to utilize reuse towards the sustainability. But this water may contain high amount of pathogens as compared to fresh water. Okay, so once these pathogens are present in this water, we spray the water or we use that trick for irrigation, and these pathogen in this water can be attached to the crops due to adhesion process, and this adhesion process means like the bacteria and viruses are now on the leaves. So, for example, the example of lettuce or the example of cabbage, okay? And then, due to the ultraviolet ray and heat, these pathogen also can die over the time. So, what is the time required to grow lettuce or carrots? Can you tell me? Overall, in terms of number of days you need to grow lettuce or carrots, 3 months, right? This kind of 2 to 3 months, right? So that's the duration for the decay. So decay is a rate constant, like decay constant is the unit is per day. So that decay constant should be multiplied by the number of days in terms of to calculate the first order diagram or like what is the concentration of this pathogen after the decay. So what I'm saying, like this is a process of this exposure assessment. So after this decay, the remaining pathogen can be attached to the salad, and when we wash or clean this food like ready to fresh produce with water, sometimes you also use chlorine, chlorate or perchlorate, right? To get rid of or kill these pathogens. And then we pack it and then we send that to the supermarket at cold temperature for ready to eat fresh produce. But some pathogen can also grow at this cold temperature. Do you know the name of the pathogen which grows at very low temperature on fridge? Oh, perfect. 100 out of 100. Yeah, listeria. So listeria was a concern for this student's PhD work. So he need everything for listeria. So when we eat the liquid salad, depending on the day. So if it is says like the shelf life is 7 days. So if you are eating the salad on day 1, and if you are eating the salad on day 7, in which case there is a more chance of getting more failure. Day 7. So depending on the time when you buy the product. So this is a very interesting one. So based on that, we can calculate the number of bacteria we are exposed to on daily basis with the consumption pattern. Now this is the difference from deterministic model and the probabilistic model. So deterministic model is 2 plus 2 equals to 4, right? In a probabilistic model, we do not have that specific value like 2. So it can be anything in terms of the range. It can be anything between 1 to 3, 1 to 5, something like that. So we are multiplying a range with a range. We are multiplying instead of a single value to multiply by 5 equals to 10, we are actually multiplying a range of value here, and we are subtracting also a range from this multiplication. And this is the overall output. So overall output also can be a range. If your input is a range. So this is called the probabilistic model. And in multi-color simulation approach, we run several times the model. It can be 100,000, it can be 10,000, it can be a million. So what happens like each time the software picks a value out of this distribution, then a value randomly from this distribution and gets the deterministic outcome. Next time another value, next time another value. If you make histogram of all these outputs, it will form kind of a bell-shaped curve, okay, towards the normal distribution. So the model uncertainty can come from the parts, and the entire pathway can be unknown. Several alternatives are there. The input uncertainty can be associated with true value of the input unknown, limited amount of information. It reflects the degree of knowledge of the person who is doing the modeling, and then the variability. So that's the inherent property of any kind of process. So the uncertainty is coming from the person who is doing the test, and variability is the natural variation of something in the sample. Okay, so the total uncertainty is uncertainty plus variability. So this is the result from my students' work. So you can see this is the annual probability of risk. So the higher risk is associated with which one? Shigella or this one? Pathogenic E. coli. Which one? This or this? Which one is more risky? Sure. Check the unit of the y-axis. So it is inverted because the risk value is less than 1. So it is the negative log axis. So the smaller is better, right? Higher means like 10 to the power minus 6. So less risk. So Shigella poses higher risk in terms of annual probability of illness. This is important. The next next figure shows infection. So for the same kind of risk assessment model, Campylobacter poses higher risk as compared to the rotavirus, adenovirus, and so on. So these are the based on the data, those response data we have. Okay. So this is a summary of ranking. So you can also rank the pathogen based on quantitative model. So I presented something in terms of semi-quantitative model. You can do the same thing with the quantitative model, but this one is more reliable because that's the more sophisticated one. Now, these are the sensitive parameter. So we perform Spearman's rank order correlation coefficient from this probabilistic model to capture the uncertainty. We can do also Pearson correlation coefficient, but Spearman's rank order correlation is more reliable because it can be applied to non-parametric data. So if you have limited data, if you do not have the data which is normally distributed, then you can also use the Spearman's rank order correlation coefficient. But in a nutshell, the left-hand side, the negative axis shows the negative correlation. Means if the decay constant is higher, the risk will be lower. Okay. See the negative correlation coefficient, decay constant, then chlorine treatment. So if the chlorine treatment is high, your risk will be low. Okay. So positive correlation is the consumption. If you eat more, you'll be more exposed to more number of bacteria and viruses. Getting my point? Then we have the initial concentration in the treated wastewater. So if your initial concentration is high, so you'll have higher chances of this risk. So next is the combination. So I mentioned chlorine is used to inactivate this pathogen, but high level of chlorine is also problematic. It causes problem to thyroid. As I told in my chemical risk assessment kind of slide, that excess of anything is problematic. So then tell me, how we can determine whether to use chlorine or not use chlorine? Because when we use chlorine, we are minimizing the number of bacteria and viruses, but we are increasing the chemical risk, right? So that's a challenging thing. This is called benefit risk assessment. So this is the last fundamental kind of concept. So we need to perform two scenarios. So for the first scenario, we call it baseline scenario, which is like reflecting the reality. So we use a certain amount of chlorine for the regular treatment in order to assess the chemical risk and the microbiological risk. And then we calculate DALI. So what is DALI now? DALI is a common currency. See, for example, I have Euro and you have Indonesian rupiah, right? We all are going to Russia, right? But we cannot exchange our money because we do not have any common currency. So we need to convert my euro to Russian currency. You need to convert your Indonesian rupiah to Russian currency, and then we can exchange. Are you getting the metaphor? Now you will understand. So DALI is disability adjusted life years. Means if you know the average life expectancy of Indonesian population, say for example it is 70 years, and if you are infected with that Cryptosporidium partum, like this pathogen, due to like salad consumptions or so that's the salad example. So you can get some illness or sickness, right? By getting sick or getting, uh, getting hospitalized for 7 days, you can also lose some good life from your overall lifetime. Some days can be lost. I will give you a more interesting example. Suppose I am a smoker and I get cancer at the age of 40, but I'm expected to live 70 years of life based on the life expectancy of Indian population, right? So if I die at 40, how many years lost from my life? 70 minus 40, right? 30 years lost from my life due to my death. But when the cancer is detected, I may not die the next day. So I may be ill or sick for 3 or 5 years and then die. So that 5 years will not be counted as my life. That is called life lived with disability. So life days lost due to my death plus days of my illness or sickness, that's the total number of days deducted from my life. So that is called disability adjusted life years. Okay? So for the first scenario, we calculate when you are infected with Cryptosporidium, how many days are gone from your life, and if you are exposed to this chlorine contamination with say 70 years of lifetime, because chlorine can act as a chronic exposure, like chronic toxicity over the time. It may not happen overnight. So due to this chlorine, also some days can be gone from my life. So we calculate what is the total number of days gone from my life for the baseline scenario. The next one, no chlorine scenario. But now tell me, the microbiological risk that will be higher, right? So the life lost due to this microbiological risk now, that we need to calculate. No chlorine. Okay? Now we can compare whether this is higher or that is higher. So then we need to decide which one is better. So for example, there is say 0.9 years per 100,000 population for the baseline scenario, like with the use of chlorine, and without using chlorine, that is 1.1 years per 100,000 population. Now tell me, should I use chlorine or not? And why? This score is lower, right? That's better. So baseline is better. That is too obvious. That's why we use a little amount of chlorine to kill all these pathogens. So that's the benefit risk assessment. Now you can relax, no more understanding, you can just see my field of interest. So this is my field of interest, this is the dimension of well-being. You can start from social, spiritual, intellectual, physical, environmental, occupational, financial, and emotional aspect. There is no starting point, it can be interlinked. I focus only on the physical and environmental aspect, such as I focus on air, water, like heavy metals and metalloids, like social distancing and what is the probability of risk, that kind of thing, like communicative and non-communicative disease. And then in terms of food, so food is the area. We evaluate what is the risk from eating X, Y of food, so food safety. So this is the microbiological risk. I also do the chemical risk for nano or microplastic, engineered nanomaterials, mycotoxins and pesticides and fertilizer residues. And then also benefit risk assessment. Another example, frying pan. Can you tell me why we need to conduct a benefit risk assessment on coated frying pan? Don't get afraid. Do not, I mean, you should not have fear of failure.
Sometimes something
Yes?
is contaminated output.
Yeah.
Right.
Yeah. So the coatings can be a problem. But coating will reduce the amount of oil intake, right? But for without frying pan, coated frying pan for use stainless steel, then maybe will the intake of oil is higher. So we need to calculate two scenario, one without the coated pan, and what is the tally based on the bad cholesterols and all. And the next scenario, lower amount of oil, but higher amount of coating, nano coating, uh, and we need to plus, we need to sum up the tally for those two and then compare in the similar way I presented for the theory. Then we can compare. Is there any benefit of using coating on the frying pan or not? Okay. Then also, I focus on the climate change scenarios and all. So this is some area of interest, chemical risk and microbiological risk. You can go through that. If you are interested, this is my Google Scholar link. If you want to read more, you can go through my published literature. Now, in the end, I should say, the beautiful thing about learning is no one can take it away from you. And there will be a break regarding the facilities we have in Ireland. And then I will go through only the future perspectives if you are interested doing masters in European country or in Ireland. So I can give you the overall structure. So it will be a fun session. Okay. So if you want to take a break 2-3 minutes, you can take, or you can actually watch the YouTube video now. So you can take a break just watching it to save some time.
Very good. I think it's very good.
But this YouTube video is available on the net, so you can also search it on YouTube. Now it is better. So that's our engineering building, and we also have. So this is mainly the material science, or sorry, material engineering people are there in that engineering building, but we have total 6 in engineering departments or inside school. So we have our own buildings surrounded by, the main buildings surrounded by all these buildings. So let's go to the next one. Open view. Okay. Okay. Here's the. Yes, it starts from here, I think. Okay. Can you see my screen? Very easy question. Yeah, that's what I was. Ah, how to stop sharing? This is the- it keeps it. It keeps on. Was it sharing your screen? Yeah, yeah, yeah. This one is very much. That's the problem. Can I make it a main display? Share the entire screen. Oh. One. Yeah, one. Okay, sorry for that. So here we are. Destination Ireland. So you can see on the map, we have a great distance in terms of the flight also. It took me 24 hours to reach here from Dublin. And this is kind of the calm landscape in Ireland. We have two heritage sites. So this is in County Kerry. So this is a part of, I think, Wild Atlantic Way. This is something I wish to do every summer, going for a road trip. And why Ireland? This is kind of one of the safest country in terms of the business. We have a great potential for businesses here. Means like it will create more opportunity. It creates more opportunity. In terms of happiness index, it's the rank is 13. 50% of the population look like this young population. We have quality education system, and it matches the economical need. So the education system is designed in such a way that the students can also contribute to the economy. So out of 5 of the top 10 employers, they have their office in Ireland. Okay, Google, Amazon, Alphabet, Apple, Samsung, take any name. Okay, so this is Dublin. This is called the dock area. So this is kind of the Silicon dock, or kind of the hub of these all multinational companies in Dublin. The list is very big. I cannot read all these companies' name, but you can have a look on all these logos. Okay, you can look at the screen. And in terms of the sector, we have booming sector in terms of IT, medical sector, engineering, food and agriculture. That can the most important stuff. If you're from food technology background, then pharma, biomedical, and finance services. So this is Dublin, and this is the kind of the hub of these all companies, and it is accessible. Means like you can reach Dublin from any part of the Ireland. It takes 2 to 3 hours with expressway. It is connected with rail also. Then it is easy to navigate. You can also take ferry. As Europe's trade capital, and Dublin dock is very famous for like port. Dublin port is very important in terms of shipping activity. We have mountains to see everything. Gateway to Europe. It's a small country, but the landscape or the land use is it's kind of quite diverse. Uh, some cities are coastal cities. I live in a small town, which is also coastal. And that's our campus in UCD. This is our kind of engineering, we call it engineering lake, but this is not the main lake, it's kind of a kidney bean. We call it a kidney shaped lake sometimes. And our engineering building is next to that. So that's our School of Law. And this is on the right hand side, you have the Queen's Business Building. And this is the distance. So it's kind of 5 kilometers from the Silicon Dock area. And UCD's campus is one of the largest campus in the Europe in terms of the urban kind of area, if you can consider. So in a city, you cannot have this big campus anywhere in the Europe. So in the College of Engineering, where I am situated in, we have 6 schools. We have first performance is for a number of reasons. So number one choice for the Irish undergrad students based on the employability. We have 8 UG offerings in 6 schools, and then we have more than 30 top masters program, and we also have research masters program in our university. So this is the college at a glance. We have 207 plus academic staff, 177 research staff, and all. So these are all facts. We have more than 400 PhD researchers. Number of publication in last 5 years is more than 6,150. And there are other fascinating fact, like in terms of the research funding, we secured more than 170 million euro last 5 years. So these are the master's program. If you are interested to visit Ireland, the list is also big, but I wanted to accumulate everything in one slide so that you can have a look in a very short time. So we have digital technology, we have robots, we have data science and technology kind of which are very happening and booming sector now. We have conventional or classical food engineering, electrical engineering, civil engineering, and so on. From the mode of delivery, it's like 1 year, we have 2 year program, we have also part-time program. In terms of the engagement, so we have a UCD connection. So after leaving UCD as a student, you will be connected to the global alumni base, and that is very important in terms of if you are getting some problem with your job and all, right? So it's always important to have good connection with your alumni. And with that, we have some facilities as a student. So this is the first choice for the student because 25% of the Ireland's graduates come from here, 30% of the Ireland's PhD are from here, more than 600 peer mentors, and then we have the best in class student support services. We have 50 official clubs. Like if you are interested in swimming, you can join a swimming club. If you are interested in mountaineering, interested in kind of sailing, name any. So we have more than 50 official clubs, 80 active societies, a dedicated student society, and excellent on-campus accommodation for international students also. UCD is also building some new buildings for international students or maybe national students who require this hostel facility. So this is kind of our the breeding place for the startups. So we have Nova UCD where the researchers are trained to file patents and to start new companies, and the industrial collaboration is now encouraged, and this is UCD ranked as one for that. And we also secure a lot of funding in terms of industrial collaboration. So this is kind of a normal day in our university going graduate. And this is the way we support our students in terms of the recruitment fairs, academic internships, in some programs, optional career development credit bearing modules, dedicated career network for support, career network support for students, and also for postdocs sometimes. So these are the companies. This is a big list where our graduates secure their job after their study. This is the most important slide in terms of your visa and work permit. So undergrad student can get 1 year of job permit after completion of their course. The master student can get the stay visa like 2 years to find a job. So we call it 1G. And then you can apply for the critical skill job permit, which is kind of permanent residency. When you secure a permanent job or when the criteria matches the critical skill requirement, so you will be getting stamp 4 on completion of having stamp 1, which is the critical skill, for 2 years. And then in terms of the part-time work for a full-time course student, you will get 20 hours for the part-time work. So the key research areas are energy, environment, health, Internet of Things, manufacturing and materials, and creativity and design. So these are also some academic research centers where we have the multi-dimensional kind of collaboration, multidisciplinary research work. And this is the link for the undergraduate programs, but I'm not explaining it. So this is kind of the master's program we have in terms of digital technology, environmental technology. So these are all 1 year program. So we have 2 year program. So for you, most important stuff is in biosystems and food engineering, the second one. So that's our school. So we also have some part-time programs. I'll share the slides with you after my talk. So we have some top graduate program also from the School of Architecture, and these are some useful links. So this is also very important for the visa requirements. Some country, the postdocs can get kind of a waiver for their tax, but I found like Indonesia is not in that list. But the thing is like it's always updating. So have a look in that website. If there's some update, you can. So because like 2 years of tax saving is a great amount of money. But the thing is like if you go to Ireland for the first time with this job, and if you work in academia or the research field, then only these 2 years of tax waiver rule applies. So if you are going to the IT sector, you will not get that. So this is the entry requirements. So we expect 2:1, 2.1 or 3.08 out of 4.2 score. And the English language requirement is kind of, I think, 6.5. That's the minimum requirement for the IELTS. And individuals should not be less than 6. Like listening, I forgot actually, I did that in 2014. I think it's writing, listening, speaking, and one understanding something, right? Reading, yeah. So, long time. Sorry. So we have three kinds of scholarships. One, global excellence scholarship. So that is 50 to 100%. This is very nice one. The first one. Then we have the international student scholarship. You do not apply, you will be automatically assessed based on your application. So the first time is kind of a competition. So if you win, then you can get. But the thing is like during the application, please highlight your other curriculum activities. If you are good in sport, if you are good in debate, painting, traveling, making digital art, communication, anything, any kind of extracurricular activity, because we also value them alongside your marks and all. And also if you have some kind of vulnerable background, if you have humble background in terms of you cannot afford your fees and all, mention that with evidence, and then the authority actually checks, and sometimes you can be given some special scholarships. So be in touch if you're interested. Then we have the college VPI innovation kind of a scholarship, so that is up to 100,000 euro. So this is the global center, global lounge when like where all the international students chill out. We also need some common room. So this is a fancy room. When I was a student, I spent a lot of time there. So this is me and my professor, where I actually did my PhD under Professor Enda Collins. Now we became colleagues. So we have more than 21 faculty, 2 administrative and 2 technical staff, 25 research staff. By the way, that's our School of Biosystems and Food Engineering. Approximately 280 full-time equivalent students, including 65 research students. More than 5 million research funding we acquire annually. So that's very high based on the total number of faculty and the resource we have. 4 highly cited researchers in our school: Professor Paul Group, Professor Sun, Professor Colin O'Donnell, and Professor Enda Collins. So this is the bigger picture of all this faculty, but this is as of 2024, I suppose. We have 3 or 4 new members in our school. So that's our food force plus. So you must be knowing that fine force is kind of an extension of, I think, the move forward from the food force, as far as I know, because I am not directly involved into this, like Professor Enda Collins does. But I also teach, I developed the predictive modeling course in UCD, along with Professor Cummings. And when I go outside, like out of the country, he teaches the model. And when I think next month, then I'll be going to Dublin for teaching. So then I'll teach the model. So we also feel like education is the manifestation of the perfection already present in man or woman. Means like you all are brilliant minds. You just need some, proper channel. So being a teacher, it's our duty to give you the path, but everybody is equally unique. So that's the kind of motto we have. So this is the Conway Institute. We also go there for biological testing, and we have the science building here. This is our main lake, and oh, sorry, I didn't use the pointer. So that's the Conway building for the biological lab. This is the science building next to the main lake. We have the library here. That's our school. Okay, that's our school. So we have four pillars: food and bioprocess engineering. You can read it more than me because I'm from civil engineering background, but I do statistical modeling as applied to food now. But you are hardcore food engineers. We have circular bioeconomy and green energy, and we have environmental and agriculture technologies and biosystems analysis and modeling. So that's kind of four pillar of like with that we need the sustainability criteria. So these are different taught programs, and also we have like 2 year ME biosystems and food engineering. Some of you know Ronald. He's an associate professor. He's originated from Indonesia, I suppose. Then he studied in Australia. So he's a good friend of mine. And then you probably know Professor Enda Cummins and me. You know now. So I'm the program director of a new undergraduate program, Sustainable Systems Engineering. And if you're interested in any of this program, you can like reach out to the program directors directly. So I have their emails, or you can also drop us an email. So this is kind of some snapshot of the feedback from our students. So I will not extend that more because it's already 3. So you can have a look, you can read all this at your convenient time. So this is another one, MSc in Digital Technology and Sustainable Agriculture. So we introduce robots and all. So this is M engineering, food engineering. So we call it M engineering science. In food engineering, it's kind of a fusion of engineering and science. This is 1 year full-time course. And this is the Master of Engineering in Biosystems and Food. So this is the 2 year ME program. So most of our students actually, if they perform well in masters, they secure kind of a PhD because like the PI, the professor, they have some fund from the projects, so they are absorbed. So I did my masters, and then I scored well. 1:1 honors I got, then I got the PhD funding in the same school. So there's a, like we call it sky's the limit. So there's a small, I think, again animation. I'm afraid of to play, but I think it should work.
Efficiency of agribusiness supply chains by minimizing waste using big data and Internet of Things sensors. Food waste is a serious problem in the EU. Nearly 18 million tons of food, equivalent to 150 billion calories, are wasted every year in the EU. Almost very long food supply chain. Reducing food waste is of highest priority in the EU. The EU is committed to halving food waste by 2030, focusing on all stages of the supply chain, which will also avoid 5.5 million a year in CO2 emissions. The two main benefits of reducing food waste are increased food availability, as well as the ability to save resources such as water, energy, labour, and fertilisers. Brilliant will adapt to new and existing Internet of Things and big data technologies to best fit the needs of the food supply chain in West Europe.
So now we are actually integrating AI and digital technology to minimize food waste.
Open spots by looking at what is happening inside the transit warehouses with the help of sensors connected to the cloud. We aim to reduce food waste in the following ways: tracking the quality of fresh food using sensors as food travels across the supply chain, both using traditional sensors such as temperature, humidity, light, vibrations, as well as newer sensors such as Raman spectroscopy and 3D fluorescent spectroscopy. Uploading data from these sensors into the cloud server and monitoring the data using automated big data technologies. Contacting food owners using smartphone apps as early as possible in the case of any potential loss of food quality and suggested to save the often before it becomes waste. Analysing the sensor data to bring out long-term strategies for reducing food waste in North West Europe in the long run. Remit will also use business analytics and decision support systems to link to nearby contributors, such as local community markets, restaurants, charities, and food banks, for faster rehabilitating of waste. Our partners span across Northwest Europe, namely Ireland, Netherlands, France, and the United Kingdom. Remit is a transnational territorial cooperation project implemented jointly by partners from universities, business development organisations, and technology firms. Our partners are the universities fellowship in University.
So these are the partners for the project. So this is kind of the overall schematic of the project. And then we have the high value biogas product from residual agri-food biomass bioanalysis. So that's another project in terms of the circular bioeconomy. We also have another sensor-based project. It's called Smart Food. So we look at the value chain for the food supplies and communities in order to meet the zero food waste criteria. So this is another project called Watson. So we detect the food fraud. I think this is a major concern now because food fraud is not only is cheating people for the money, so they are paying for something which they are not getting, but at the same time they are doing the food fraud with some chemicals which are very harmful for our health. So chemical risk point of view. Next, this is Ronald's project. So he works with the microalgae. He also creates biofuel for flights. So this is a very fascinating work. He has a big lab now, I think, more than 20 or something, I think, PhD and postdocs work with him. And thank you very much. My entire presentation is dedicated to people who are really special. And let's see.
Have any question? Other? Oh,
Yes.
yes, please.
Regarding qualitative microbial risk assessment, is regarding to ready to eat salad. Yeah.
That's my final paper of the PhD thesis.
Oh, okay.
Go on.
Yeah. So my question comes from that. From the paper, you analyze several parameter models, and then from that, you calculate the exposure assessment. Yeah. So the exposure assessment is calculated from the final concentration of the microbial count and consumption data.
Yeah.
So my question is, what if we calculate the exposure assessment just from the final product? I mean, maybe.
Because in that way you cannot. So it's kind of you are the Sherlock Holmes, and there's a murder.
Yeah,
You need to investigate the crime.
because
I'm telling you, I listen to your next part. I'm just so you are the food inspector, say. So you identify what is the root cause of that. So which parameter in the in the bag is contributing that problem to higher magnitude.
Okay.
So it's kind of identifying the hotspot of the module, identifying the root cause, and how we can improve the process.
Okay.
Yeah.
So,
That's correct.
yeah.
So we can actually check before eating what is the number of bacteria, what is the number of things. That's called the validation. So we predict the model, and from the literature we actually validate our model whether I'm doing a mistake or not. So I also compare my finding with those kind of studies and found that we are in the same ballpark.
Okay.
Yeah.
So if my undergraduate student
Yeah.
will do the exposure assessment, could we count exposure assessment from the what is just we analyze the microbial in this example what our coliform and then we multiply by the consumption data. Is it enough to we call it as a quantitative microbial assessment?
The problem with total coliform is it's an indicator one, so it is not a confirmatory test. But from the industrial point of view, they cannot go for test after test because they are not a research kind of body. But for that, it is fine that if that is the industrial standard, you can go. But from the research point of view, it is not a confirmatory test. So in indicator means like there can be. So indicator is for all the coliform bacteria, right? So it's kind of a group. So it can be say E. coli, it can be say Listeria, and so on. So you do not know what is the exact concentration of the pathogens in the total coliform. It can be none of them can be toxic. So none of them can be pathogenic. So there will not be any risk. But maybe all of them can be pathogenic. You do not know that. So total coliform is giving you an idea. So these are screening tests. If there is no coliform bacteria or the level is very little, so the other pathogen in the salad or the food product will be also very low. So that's the first thing we do. And then for the confirmatory, we need to conduct more tests bioselectively, like if you change the different agar plate for the bacterial growth, you do the cell culture in the lab, then we will identify that which bacteria is there, which pathogenic organism is there in the food.
Mm.
And then you can use select the specific dose response model for that pathogen. Because for the indicator, we do not have any dose response model. You can only compare with the industrial standard, like the threshold limit and the level you are getting from the experiment. And you can say like how much we are safe, how that kind of thing. So that is not the confirmatory test, but from the industrial point of view, it is okay. Regulation point of view.
Okay.
You can do one more thing. You can do you can analyze the entire process chain where you are making the salad box. I mean, you can do a gate to gate study. So the raw material is coming to your factory, and then you are doing kind of different steps in order to make that vacuum sealed salad box. So at each level, what is the concentration of that bacteria? So you will know that if there is cross contamination in the process of chopping. So if you do that calculation, then you can make a plot of a bar chart or column chart with the aiders and all, and from that you can actually easily identify which step is causing problem to my overall quality of the food.
Okay, thank you.
No problem. Yes, please.
Because research that pointed out on the topic about antimicrobial resistance is when I worked at the ecological in the review, and my proposal research, I wrote about the experimental study to evaluate the number of the bacteria, pathogenic bacteria in the food. So after I learned about the semi-qualitative and qualitative model. How the methodology or this methodology can support the experimental data, because I think my proposal last time when I wrote my proposal, all of my methodology was about molecular examination, and then I evaluate the local member of bacteria, and I also evaluate the antimicrobial gene.
Yeah, so did you do the whole genome sequencing
Yeah,
to calculate what is the percentage of?
yeah.
That's nice. Yeah.
So, if I do the experimental method like that, do the semi-qualitative model and the
You do not need same quantity model for that. You need quantitative model because you have good data. Semi-quantitative and qualitative is done when you do not have any data or very limited data. You have, so how can I say, like you are wearing a Gucci sunglasses, but you are riding a old kind of scooter or something. So it's mismatch. So you have high quality of data to support that. You need a good model. So it's quantitative is the only model which can actually utilize your whole genome sequencing data. So the percentages and all. So with the dose response model, you can consider that percentage of the pathogenic cells instead of the entire number of the pathogen.
but export.
Of course, like for quantitative, we need those kind of data. So you're on the right track.
Oh.
No problem. Yes, please.
I think you're right. Where I'm from, our African document,
Right.
I'm curious about how to implement this kind of. What you do, how.
Nice. I'm actually chairing a session, not session, I'm the working group leader of bio aqua prospection. So you can have a look, and the thing is like the risk assessment can be done on for the fish. Like you can also do the dose response model for Cubio, Yersinia rookery, and can do that for what else? Probably the entire list of the methods, my posters on the notepad. Yeah, so there's a whole lot of freshwater and rainwater pathogens which can cause problem. And then I think those are the main ones, Nutrio and Yersinia. Those are the main causing problems. So you can do a first you need to identify the hazards. So if there is a kind of outbreak, disease outbreak in your farm, you need to identify what is the main cause, which pathogen caused that, whether it is pathogen or the chemical imbalance in the water, which caused it. So postmortem analysis, sample from the stomach, and then you can do the cultural analysis, and then you can identify what's the main cause. Once you know that, you can actually investigate more what is the threshold level of the pathogen in the water in the aquaculture. If your monitored levels are less than that, you are fine. If it is kind of sometimes increasing, sometimes no below, then you can do a quantitative risk assessment to identify what is the probability of the death, like the mortality, because the value of the fish is very high sometimes. If there's an outbreak, thousands of fish can die in one day.
Or is that?
Economical loss. So your response is the dollar or Indonesian rupiah lost can be. What is the probability? So 100% probability means like you lose everything. 10% mortality means like 10% of losing the entire money. Know what I mean? Yeah. So 10% loss and then 100% loss. And this is the dose. So this is the number of bacteria. So you can extrapolate that or you can come up with that kind of solution.
And recently, actually, we have rejection from tax market. When frozen products.
Yes. Yeah.
Contaminated, with, radioactive. And I think, this, approach is also suitable to mitigate this kind of, risk last year.
So is it biological problem or chemical problem?
Chemical.
Okay. So why it is a problem? So that is hazard identification. Exposure assessment means like if you take sample from all the fish farms here, if it is, I don't know, it is dried fish or it is a like, I mean, the fresh fish, frozen. So if you do sampling from say 50 farms or 10 farms, and if you identify that chemical and if it is within the limit, there should not be any problem. So you can actually challenge uh, the person or the authority. But if something is there because something bad happened in the past, so you have to be very careful in terms of increasing the standards so that you can reapply for the re-application and we can get the certification. That can be the possible solution.
Kind of, consequence and provide
Yeah, and you need to identify what's the alternative. If chemical A is not be applicable, if chemical B is not that much hazardous and does kind of 90% of the same kind of thing, so why should we go for chemical A? We can go with plan B. So these are kind of risk management system.
think very great, issues as well.
Yeah, if you have any kind of problem, if you face any kind of problem, you can approach me. I'll be very happy to guide you through.
Okay, I think it's enough for today's Q&A session due to your time is up.
Okay.
So thank you very much, Dr. for such an insightful and inspiring presentation. We're also sincerely to thank to all participants for joining the session and for your active engagement. We're here today. The lecture has grown our understanding and inspired us to keep learning and innovating. That concludes our guest lecture for today under the Fine Forest Project. Stay safe, stay inspired, and we look forward to seeing you at our next events. Thank you and have a wonderful day ahead.
Thank you very much. And thank you very much uh, for the support for the IT, for the screen share and the Zoom. Thank you very much for that. I appreciate it. It's nice.
Before we close, can we take a picture for the community?
Take a picture with all the
Cek, please buat kameranya bisa dihidupkan ya teman-teman. Mau di foto secara online ini.
offline first, right? Yeah. Okay.
Yeah, and the thing is like if you can come in the back, so people also can see you in the frame. Okay. So yeah, just gather in the back portion of me so that in this frame you are there. I mean, people can see you. You can stop the YouTube streaming now. This is like personal data.
Oke.
Yeah, so I request all the online participants if you can turn on your video. This is not absolute absolute. If you can, that would be great. Can see you. Yes.
Oke, di on semua ya kameranya. Ini mau di screen capture dari.
Download your video. I'm giving you another 2 3 minutes, and then we take a screenshot of that.
Oke, good. Thank you.
Thank you. Bapak for joining.
Yang lain bisa dihidupin kameranya ya.
Yeah, so you know how to take a screenshot of this. So it's like this complete print screen. This one.
You will do it.
Okay. Please send it here.
Wait.
Do I put down off my computer? No, I should not.
On.
Okay, on.
Here.
Okay.
1, 2, 3. Okay. Good. What for? Yes. Wait. Wait a minute. Okay, again. 1, 2, 3. Okay, thank you very much. All right. It's not you, because maybe they are waiting. It's great. Yeah.
Thank you teman-teman semuanya.